Hello again, and welcome back to another edition of Awesome Algebra 2 Notes with Miss Faust. Today we are going to take what we learned last time about finding common denominators with rational expressions and extending that to actually adding and subtracting rationals. So the first thing that I just want you to think about is if you were doing a problem, so this is kind of a review problem. I certainly hope you've seen something like this before. If you were doing 1/2 plus 1/5, somewhere in your mathematical past you learned that in order to combine fractions, you need what's called a common denominator. Preferably a least common denominator, especially when we're working with rationals, but any common denominator is fine. So in this, to find the LCD, you'd look at the 2 and the 5, and you'd multiply them, right? Or usually you would have written it as 10. And then hopefully you remember that you multiply the top and bottom, because when you multiply on the top or on the bottom, you also need it on the top. So to get that 10 here, we need to put times 5 on the bottom, which means we also need to put times 5 on the top. That way we're keeping a 1 there. And over here, to get a 10 on the bottom, we need a 2 there. So we also need to put a 2 on the top. So then when we put these together, 5 times 1 is 5. So we multiply those and we multiply those. We multiply those and we multiply those, and then we combine. So we add or subtract the numerators, and we keep the denominators the same. And those exact same steps are going to apply when we're working with rational functions. So here we're going to do 5 plus 2 is 7 over 10. And that's our answer to 1/2 plus 1/5. So when we work with rational expressions, we do the same thing. So when we add and subtract rational expressions, the first thing we're going to do is we're going to factor any denominators. And that's our first step in looking for that common denominator. If these numbers had had factors of the same thing, then we would want to know that. Once we factor the denominators, we find the LCD, or the least common denominator. And if you don't remember how to find the least common denominator, just go back to the video before this and you'll find all the information you want there about that. Next, we rewrite both expressions. With that LCD. So that's what we did up here when we multiplied, and then we changed that into 5 over 10 and 2 over 10. We're keeping everything equivalent because we're multiplying by 1, and then we get a common denominator, and then we add or subtract our numerators, and the denominators stays the same. Okay, so those are the steps when we add and subtract rational expressions. For our examples, I gave you some examples in class on a piece of paper, so if you have those, now would be a good time to take them out. If not, you can always just copy them down in your notebook here. I'm going to do them on that handout though, just because it's a little bit easier for me to keep track then. So what we've got, and I think that the spacing and everything will be fine on this. What I did here is I sort of led you through the steps on these first few, and then the later ones I left you to do a little bit on your own. And watch as many of these as you need to. I'd say watch at least the first 3 and then decide if you need to see the last 2. Or an even better thing to do would be to try the last 2 on your own, see how you do, compare answers, etc. But I'll do all of them just so you can see what's going on. So when we look at this first one, we have 3 over x plus 2 plus x plus 1 over x minus 5. Nothing to factor here. So if possible, nope, that's not possible in this problem. So our LCD is just the string of denominators. So our LCD is x plus 2 times x minus 5. So what I need to do now is I need to multiply both of those in order to get the least common denominator. So my original problem again was 3 over x plus 2 plus x plus 1 over x minus 5. So what I need is I need to multiply by the missing parts. So this already has this x plus 2, but it doesn't have that x minus 5. So I'll put that there. If I put it on the bottom, I also have to put it on the top. So I do x minus 5 over x minus 5 times that. This one, the x plus 2 is the missing piece. I already have the x minus 5. So I put x plus 2 over x plus 2. And now I need to simplify these a little bit. So if I look at just this first expression, this has 3 times x minus 5. So I'm basically going to distribute the 3 to both parts of that. And I get 3x minus 15 over, don't do anything with the LCD, just leave it as it is. Just keep writing it over and over. Okay. And then on the top here, I have x plus 1 times x plus 2. So when I simplify that, I'm actually going to make a box or use FOIL. So first times first is x squared. X times 2 is 2x plus 1 times x, or 1x. 2x plus 1x is 3x. And then 1 times 2 is 2 over, again, my common denominator. So notice here our denominators are the same. That's what we want. Now we can add our numerators. So we don't subtract in this one because we just have an addition problem. So we write 3x minus 15 plus x squared plus 3x plus 2. And again, I'm just taking all of this and putting it here, and all of this and putting it over here, putting addition in the middle, and I'm keeping my denominator exactly the same, but I'm just going to write it once now. Now I simplify. So I look for all my x squareds first. I just have 1. I look for all my x's. I have 3x and 3x, which is 6x. And then I look for all my numbers, negative 15 and 2, and negative 15 and positive 2 is negative 13 over x minus 5 times x plus 2. Nothing more we could do with that. So my simplified expression is x squared plus 6x minus 13 over x minus 5 times x plus 2. And my excluded values, remember, come from my denominator. So x can't be positive 5 or negative 2. They're the opposites of your denominator. Okay, so let's do a couple more and see how this works so we can get used to it. So example 2. Again, we want to look and see if there's anything we can factor on the bottom. So I look at this and I notice that x squared minus 2x is really x times x minus 2. So as I move forward with this problem, I'm going to use this denominator, the factored one, as I go on. So I want to write my LCD. So I just take all my factors, x minus 2, and I don't need to write another x because I already have one. If I put another x, I'm just making my life more complicated. You can see this already isn't very simple. If you have extra x's, just trust me on this. You don't want them. So rewrite with the LCD. Well, look, the first part already has the LCD. Well, that's not so bad. So we just write that minus x plus 7 over x. So my missing part now is just the x minus 2. So I put that on the top and bottom, right, because I need x times x minus 2 on the bottom. Now I have the same denominator in both parts. So again, my 4x over x times x minus 2 isn't going to change. Here, I FOIL this out. X times x is x squared. 7x minus 2x is 5x, and 7 times negative 2 is negative 14 over x times x minus 2. Now in this one, I'm going to subtract because I have a subtraction sign there. Notice our denominators are the same. Resist any urge you have to cancel this x and that x, then you won't have a common denominator, and we need a common denominator, so leave those x's there. So what we're going to do is we're going to write 4x minus, and it's really important to put this in parentheses, or else you're going to forget to distribute that negative. So 4x minus all that over x times x minus 2. Like I said, that negative gets distributed, so if I make that plus and then a minus, and a plus, so I really have 4x plus negative x squared plus negative 5x plus 14 over x times x minus 2. Well, now I just need to simplify the top. So I have a negative x squared. 4x minus 5x is negative 1x, and plus 14 all over x times x minus 2. Notice our denominator doesn't change at all here. It always stays the same, and we're just combining the numerators. Excluded values then, again, come from here. So x can't be 0, right? And x can't be positive 2. The 0 comes from that one. The positive 2 comes from that one. And you're done. So as you can see, it's not really that much new stuff. It's just putting it all together in a slightly different way. So let's go ahead and go on and do example 3, and then we'll go from there. So x plus 4 over x squared minus x minus 2. Well, now I look at this and I go, okay, that looks like it can be factored. So I want to think of two things that multiply to negative 2 and add to negative 1. I'm not going to show you the box here. You guys know that method, and you're welcome to use it. But I'm just going to use inspection and say if I need two things that multiply to negative 2 and add to negative 1, I can see that's going to be x minus 2 and x plus 1. Don't feel bad if you can't do it as fast as me. You're not supposed to be able to. You're not nearly as old as I am. I've been doing this far longer than you. Multiply to negative 6 and add to 1, so that would be x plus 3 and x minus 2. Now, again, those are going to replace my denominators for those as I move on. My LCD is all of my denominators put together. So x minus 2, x plus 1, x plus 3, x minus 2, but I already have x minus 2. Not going to write it again. It's only going to complicate things. So this is my LCD. So now I need to just rewrite those expressions. So x plus 4, I already have x minus 2 and x plus 1, minus x minus 1 over, I already have x plus 3 and x minus 2. So I think about the missing parts. This one has an x minus 2 and an x plus 1. It doesn't have an x plus 3. So I put x plus 3 there, and it also goes on top. This one then has an x plus 3, it has an x minus 2, it doesn't have an x plus 1. So I put that there and there. Now I simplify a little, so x, again, we're just always using FOIL or the distributive property of the box method. We're multiplying out the tops here. So x squared, 3x plus 4x is 7x, 3 times 4 is 12, over x plus 3, x minus 2, x plus 1. Now you're glad you don't have to multiply out the bottom, right? It'll just take more time. X times x is x squared. X times 1 is 1x minus 1x. Well, that's nothing. Negative 1 times 1 is negative 1 over x plus 3, x minus 2, x plus 1. Yeah, it's annoying to write over and over, but at least you don't have to multiply it all out, right? Okay. So now we are going to subtract again because we have a subtraction sign. So we're going to write x squared plus 7x plus 12 minus, in parentheses to start, x squared minus 1 over our denominator. And again, these just came from here and here. Okay, and notice now we only have to write the denominator once, so things are getting a little bit better. So we have x squared plus 7x plus 12. We distribute that negative, so we get minus x squared and plus 1 over our least common denominator, least being a relative term. And now we simplify. X squared minus x squared is 0, so I have no x squareds. 7x and no other x's, so I have a 7x in my numerator. 12 plus 1 is 13, and my denominator stays the same. Finally, my excluded values, so I look at these. Opposites, so x can't be negative 3, positive 2, or negative 1. So that's 3 examples. This one is about as complicated as they get. That's why I did that one in the first couple. I did 2 subtractions instead of additions because people forget to do that distributing. So let's turn the paper over and try a couple more. Okay, so let's look at these examples. Again, I would encourage you to try them a little bit on your own too, not just watch me do it, because sometimes you just need to process on your own. And then when you get stuck, come on back and see what we did. So first problem, nothing I can factor. The way I know that is I have nothing squared and I have no numbers in front of these in the denominators. So I'll just go straight to writing my least common denominator of x minus 3 times x minus 1. And then what I notice, again, is that I need to multiply the x minus 1 to that part and the x minus 3 to that part. So I have x plus 8 over x minus 3 minus x minus 2 over x minus 1. That was my original problem. Now this x minus 1 needs to go with this one. So I'll put x minus 1 over x minus 1 there. Like to just keep the parentheses in there as well. And this side has the x minus 1, but it needs the x minus 3. So we put that there. Now we leave our denominators alone. X minus 1, x minus 3, minus something over x minus 1 and x minus 3. At this point we need to multiply the numerators, so I haven't been showing this step, but to multiply those, what we'd really do, if you need it, is you make the box x minus 1 and x plus 8, so you get x squared, 8x, negative x, and negative 8. And then you combine those two, so you get x squared, you get positive 7x, and you get negative 8 in that numerator. Again, so this is going in between those two steps, so you can see where that's coming from. And then for the second part, for the numerator, I need to do x minus 2 times x minus 3. So x minus 2 and x minus 3, x squared minus 3x minus 2x and 6. So x squared minus 5x plus 6. And now I have my common denominators. Those are not going to change, x minus 1, x minus 3. So I need to subtract all of this from all of this. So I have x squared plus 7x minus 8 minus, in parentheses, x squared minus 5x plus 6. So I distribute that negative, make that a plus, make that a plus, a minus. And I get x squared plus 7x minus 8 plus negative x squared plus 5x minus 6 all over x minus 1, x minus 3. Now I just simplify that. So I look at it and, oh man, I haven't used any sound effects yet in this video. Well, that's okay. X squared and negative x squared, cancel right out. 7x and 5x is 12x. Negative 8 and negative 6 is negative 14 over x minus 1 times x minus 3. Okay, so we're just combining like terms on the top, keeping our denominator the same, and x cannot equal 1 or 3. Opposites of those. Good? So we got one more to do, and we'll be all done for today. Example 5, again, if you want to stop and try this one on your own, I would certainly encourage you to do so. I think you have the skills now to do it. But if you're feeling like you just need a little more help, well, by golly, that's what I'm here for. X squared minus 9, oh, I gotta factor that. X plus 3 can't be factored. X squared minus 9 is a difference of squares. If you need to go back to that gold sheet so you know that, you can. Factors into x plus 3 times x minus 3. So I'm going to use that moving forward. So one of my denominators is x plus 3. The other one is x plus 3 times x minus 3. I don't put 2 copies of x plus 3 because I've already got it here. So now, let me do some rewriting. So I have x minus 5 over x plus 3 plus x minus 10 over x plus 3 times x minus 3. Well, that's nice. This one already has my least common denominator. Don't need to multiply by anything extra there. Get that blue pen out of the way, sorry. I do need to multiply this one because I have an x minus 3, but I'm missing... I said that wrong. I have an x plus 3. I'm missing an x minus 3. There we go, there we go. Little box here. X times x is x squared. X times negative 5 is negative 5x. Negative 3 times x. Negative 5 plus negative 3 is negative 8x. Negative 3 times negative 5 is positive 15 over my LCD. I'm adding this time. That makes things easier. I don't have anything to distribute, so I just write it all out. X squared minus 8x plus 15 plus x minus 10 all over x minus 3 times x plus 3. So my simplified expression, remember denominator never changes, x minus 3 and x plus 3. X squared, there's no other x squareds. Negative 8x plus x is negative 7x, and 15 and negative 10 is plus 5. That's my answer. That's the sum of my original two rational expressions. And my excluded values are 3 and negative 3. Okay. Excluded values you could always find right at the beginning if you wanted to. If I just zoom out a bit here, if you go way back to when you found the least common denominator, notice that that actually gives you also the excluded values. So if you're ever doing a test and you want some credit, if you can find the least common denominator or you can factor the original denominators, you can find the excluded values and get some points. It's always better to get some points than no points. That's your extra thought for today. Have a wonderful day, and I will see you in class soon. Thank you. Goodbye.